The next topic is work, an application problem for the dot product. So imagine that your car died. The good news, it died on a level road that was 200 feet from the gas station, exerting a constant force of 90 pounds. And not necessarily whistling as you work, you managed to push the car to the gas station. So here's our gas station. Here you are 200 feet from the gas station and you're pushing at a force of 90 pounds. Continue reading here. Although you did not whistle, you certainly did work pushing the 200 feet to the gas station from point A to point B. How much work did you do? If a constant force F is applied to an object moving it from point A to point B in the direction of the force, the work W, so this represents your work, equals the magnitude. Remember, magnitude equals length of force and the distance that you traveled from A to B. So you pushed with a force of 90 pounds for a distance of 200 feet. So the work done by force is 90 pounds times 200 feet. When you multiply that together, you're going to get 18,000 foot-pounds. Work is often measured in foot-pounds or Newton meters. The photo that you can look at is a wagon being pulled, which we're going to be looking at in the next example. Work is being done. However, the situation is not quite the same as pushing your car. Pushing the car, the force you applied was along the line of motion. By contrast, the force of an adult pulling the wagon is not applied along the line of the wagon's motion. In this case, the dot product is used to determine the work done by the force. So here we go. So here's our formula for work. Work is done by force moving onto an object. So when computing work, it's often easier to use this alternative formula. So this alternative formula, this piece here represents the magnitude or the distance of the force. This piece here is the distance over which the constant force is applied. And then the last piece, the cosine of angle theta, is the angle between the force and the direction. All right, so here's the example we were talking about with a child pulls a sled along a level ground, exerting a force of 30 pounds. So here's the sled being pulled at a force of 30 pounds. There's an angle of 35 degrees. So here's your angle theta of 35 degrees. How much work is done by pulling the sled 200 feet? So you're going to go this direction 200 feet. So we're going to go ahead and use that formula on the previous slide. So I'm going to write the formula down first. So work equals the magnitude of the force, magnitude of that vector, and then the cosine of angle theta. All right. So here we go. this is your magnitude of your force. So that's going to go in for your first piece. The next is the distance you traveled. So you traveled 200 feet. So that'll go in next. That's your vector length horizontal distance, 200 feet. Then the angle theta between the force and the distance is 35 degrees. Then go ahead and pause the video and type this into your calculator. All right, so to type in your calculator, make sure you're in degree mode. 30 times 200 times the cosine of 35 degrees. Enter it into your calculator. 4,900, and I'm going to round it to the nearest foot-pounds, so 4,915 foot-pounds.